Share my screen. Can you see my screen?
Yes, sir.
Yes. Okay. Okay. So today we'll start the other way around. We'll start with the assignment because you now know about basic sockets and everything. And we'll see what is required for the assignment and then teach you those things. You will learn a very interesting new call and something else. We'll see. So I hope that you had understood the basic TCP, UDP, client server connections. Okay. One question that I got is a very valid question. I deliberately did not give it here. So just like we did that host to network short and for the port, sending the port thing, ideally that is the big endian, little endian thing is true for any integer. Okay. So ideally, when you send any integer, you are supposed to convert it to network byte order because you do not know what is the architecture of the other side. Okay. We skipped this because it's the first assignment. We're just learning the calls for the first time. And almost everybody of you will be running it on your laptop only. Okay. Maybe one of your friends and so on. Actually, I request you try that. Just pair up with somebody and send their code, get their code, run your client from here, server there. Then you actually see a good network thing basically. So, but then most of your laptops are all Linux laptops and standard Intel cores and so on. So that will not be a problem because the architecture is the same on both sides. But yes, in general, when you send integers, you should first convert to network byte order and vice versa. Okay. All right. So today, first you will do basically how a basic DNS server works. Okay, how your basic DNS query works. We have simplified it, but you will still get an idea. So you will write a client server system using UDP sockets. So DNS uses UDP sockets. Okay, even your real world DNS uses UDP. And you want to convert a given DNS name. Suppose you will send www.google.com and you want to get back IP addresses. Okay. And what happens is that usually you get, not usually, I will not use the word usually, you may get for a single name, for example, for google.com, you will definitely get more than one IP address. Okay, what do they mean? We'll learn later. Okay. But think of that there can be more than one machine somehow with the same IP address. Sorry, same name. Okay. More than one machine with different IP address, but with the same name. So we'll teach you a call today. You will just explore it. We'll just mention it, which kind of does this name to IP lookup on your local machine. You are just asking the server, your DNS server, to make that call, get the IPs, and send them to you as strings, dotted decimal string like 10.4.7.13, something like that. And the client will print all the things. Okay. So the client will ask the user, that is from the keyboard, for a DNS name like this, read it as a string, and send the string to the server using the UDP socket. The server will convert the name to its equivalent IP address and return them back to the client. And you may send a wrong name by mistake. So if no IP can be found, then you send a special address 0.0.0.0. So then the client will print all the addresses, all of them. Or if 0.0.0 is returned, then suitable message like no IP address can be found or something. And it's just a one-time thing. Okay. And you can assume that the server is iterative. Okay, for the time. So again, that was the other confusion that I heard from a couple of people. So when we say iterative server, to be precise, it means basically that it's not that the, okay. So after you make an accept call, you are in the code handling a client. An iterative server means only if this client is completely processed, whatever this client is supposed to do, okay, only then will you go back to the accept call to accept the next request. So it's iterative in the sense that it allows clients in one after the other. It allows one client in with one accept call, does everything for that client, Only then does it go back to the other accept call again to allow the next client in, does the same thing and so on. So it iterates over clients. So it's never that two clients are connected at the same time in a iterative server. Okay? But the server has not made the accept call twice. Okay, but now there is a new thing. So this one is easy. So if you read the third paragraph here first, okay. So all you have to do is to look up this function called getHostByName. You can just practice it without network. Just call it, write a small C program, call this, and the return value of getHostByName is a special structure. Look at that structure. Okay, it's just, you know, you pass the string name of the thing and you get back a array of strings which are the IP address. So there are some other parameters which you can just set to null and zero and all those things basically. Okay. So this one I will leave it up to you to read the description. Do a man getHostByName or just search Google. You will see so many code snippets and so on. Okay. Okay. But then this is the new thing. So it's possible that the server may be busy. Okay, it takes too long to respond. It's also possible, because UDP is an unreliable protocol, that either your request gets lost or the response gets lost. Okay. So the client waits for an arbitrary time I've chosen, 2 seconds. And if it does not receive a reply, then it exits. Now, typically a DNS client will try again. If it does not get a reply, it will try again. And then only after some time it will give up. So we could have done that, but this is just your second assignment and this is a new thing. So all we want you to know, so this is the new thing that you do basically. How do you wait for 2 seconds and come out? Because remember, if you just now think for a second, your server has, your client has sent a send to call and now waiting in a receive from call to receive the response, and receive from is a blocking call. So it is blocked. So if it is blocked, then how does it count the time? It cannot count the time. If I don't do anything else, it will just be blocked forever. So this is the new thing that we learned today, how to time out, how to wait for 2 seconds and time out, even though you are in the middle of a blocking call. But again, in a true DNS client, it will retry it for a few number of times before it gives up. So this is the new thing. And then 2B, we have that plus something else. Now in the same DNS, suppose that the DNS server responds to both a TCP socket and a UDP socket. So client can request over UDP, over TCP also. In a true DNS server, the client does not do that. But then DNS server to DNS server, there is some communication called zone transfer. Don't need to know what it is, which occurs over TCP. So a DNS server will have to wait for both a TCP connection doing something, if it comes, and a UDP connection from the client to respond to name to IP conversions. Okay, request. So you will need to open both a TCP socket and a UDP socket on the server side. And then you have to accept, in this case simplified, DNS name resolution request from any of them whenever they come. Okay. So now you see, you cannot, we'll see this. So we'll see this select call. This is the new thing we'll learn, which allows you to wait for more than one thing. Note that if you just think for a second, okay, if I needed to open both a TCP and UDP, I do not know where the request will come first. Maybe it will come on the TCP, maybe it will come on the UDP. So suppose in your code, if you just think about your code, you write receive from the TCP socket. But then if there is no request coming in the TCP socket, your receive is still blocked. And even if there is a request from the UDP socket, you cannot go there because the code is blocked. Okay. So just the way we have been doing things in assignment 1 will not work, because whichever one I place first, if that no request comes into that socket, but something is present on the other socket, I'm just blocked in the first one. Okay. So we have to do something to say something like this, that I want to be blocked on more than one thing together. But if anything comes in any one of them or more, can come in 2 of them, 3 of them, whatever. Okay, I should come out of that block. So I want to say I want to block on 4 sockets, but if there is any data on any one of the sockets, okay, I should come out of the wait. And when I come out of the wait, I need to find out of those 4 sockets where the data has come. So I need mechanisms for that. So all that we'll learn today. Okay. Also, we'll learn this other small thing called a concurrent server. So if you go back to your TCP example, so think about a web server. Okay, is waiting for you to give it a URL and it will download that thing for you to your browser. Your browser is the client, TCP client, your web server is the TCP server. Okay. Now, if I make a request to download a very large thing, okay, then if my request is getting downloaded, it's taking time, then anybody else's request will get blocked if it's an iterative server. Because I said at any point of time in an iterative server, at most one TCP connection can be open, client can be connected. Okay. Only if it finishes with that client does it go back to that accept call to wait for the next client. But that's not what I want, right? I want in the TCP server basically to handle multiple clients concurrently. Otherwise, while my thing is getting downloaded, my large thing is getting downloaded, everybody else basically sees nothing. Okay. So I want something called a concurrent server where we'll see what happens. The TCP server will kind of, so kind of spawn different threads to each of those threads handling a client request in parallel. So all these client requests should be handled in parallel, basically. So everybody will get something. So these are the 2 new things that we learned that you need to do your assignment to. One is the select call, which allows me to wait on multiple sockets together, okay, and come out if any one of them. And also the select call itself allows me to also do timeout. Okay, only timeout also if I want just to do timeout and so on. There are other ways of doing it also, but it allows that one thing we'll learn. And we'll see what the concurrent server is. Is it okay? So I have a question, like in your first OS lab, what happened? Like, so far have you been introduced to the fork call, FORK?
No, sir, not yet. In our first OS lab, we are basically getting acquainted to bash scripts and writing shell commands and stuff like
that. Okay. No issues. Okay. So that's another thing that I have to teach you a little bit. So it's going to be an interesting class. Let's see. So let's do one thing. Let's do the concurrent server first. We'll start with the fork thing. Okay. And then we'll do the concurrent server because it's minimum change from your last one. We'll show you code, run it, and so on. And then I will come to the select call. Okay. So here is my Blackboard. So I want ink. Okay. So first thing that we do is to learn about the fork. Okay. And that's what the prototype is. No parameters. Now this I want you to listen very carefully and ask me if you have any questions, and then I will go to code and I will show you examples and so on. Okay. So fork is a strange call. Normally when it looks like a function call and it returns an integer. This is the prototype of fork, int fork. Okay. Now typically, so you have got a program, okay, and a program is run in what is called a process. Okay, that's the OS word for it. For each program, you create one process, and that process is in charge of loading the program, running it, and so on. Okay, but then fork is a strange call. So far, all functions that you have seen, okay, there is a process, there is a, if you make a function call, just give me one second. If you make a function call, okay, then you still have one process. So one process before function call, you still have one process, okay, and possibly if the function is not void, one return value. That's the functions you have seen. Every function you make a call, you get one return value. And trust me, that you have the same program, so one process and then you have 1%. Fork is a strange call. That's why it's called fork. One process, you make a fork call. You get two processes. The original process and a child process. Okay. One return value of fork, a different return value of fork. Okay. And the return value for child is always 0. Okay. So, and some other things happen. Okay. So you see, if I do this, think of this piece of code. So I say I have some variable x equal to fork. Okay. And then I say if x equal to 0, okay, printf this something, okay, else printf that. Now, if this was any other function call, okay, that returned an integer value, what do you expect to be printed? Not for some normal function call that you. No. What do you expect to be printed?
That.
Huh?
Either this or that.
Right. So you expect is an if else, very good. Okay. That either this will be printed or that will be printed. Okay. Depending on the value of x. Now, if this is a fork call, the print that you can get is any one of these two. This, that, or that, this. Okay. Why? So here, up to this point, you had one process. Okay. At this point, you have two processes. What is the program they run? Everything from here. So both of them are running this code. But then the return value that they got is different. The child process always gets a 0. So the child process, actually this is not that if and else both got printed. But the if was printed from one of the processes, the else part was printed from the other process. Because for one of the processes, which is we call the child process, the return value is always 0. So child process printed this. And in the parent process, this is non-zero, so it went to the else part and printed that. And now these are two programs running in parallel. Okay. And they can run in any order. I don't assume anything saying that which will run first. So either you can get this, that, or that, this. In this case, child ran before this, parent. In this case, parent ran before child. Is it clear?
Yes.
This is
Sir.
kind of new thing. Okay. You're not seeing functions like this. And after this, I can do many other things that will not go into, that will come into your OS lab. Okay. We don't need that for this. But what you need to know is there are two processes after the fork call. Okay. There are two completely independent processes. How do I distinguish which one is child, which one is parent? Okay. The child will get the return value 0. The parent will get return value. So generically, if I want to write a code, I will write x equal to fork, okay, and then I will say if x equal to 0, I will say code whatever I want the child process to execute, code for child process, whatever I want it to execute, else code for parent process. So now just think as if there are two programs running in parallel. Okay, for one of them, the value of x is 0, the other is non-zero. So one of them will only execute this one. Okay, one of them will only execute this one. With me?
Yes, sir.
Okay.
Yes, sir.
Okay. So we'll see how to use that in Socket. One more thing happens. Okay. suppose I had another variable here, int, let's say int something d equal to 10. Okay, not only do they get this, each gets a separate copy of all the variables. Okay, so this also gets a copy of d, gets a separate copy of d. So both of them will get d equal to 10, but in the child process, if I modify it, okay, and I print in the parent process, these are now two different variables, as if you have written two different C programs using d in both. There's nothing linking there. That's the difference between process and threads, but then threads are a little bit more difficult for you to understand now. So we also in OS also we start with process only. So we'll stick with that. So the completely two different copies of this. Okay. Let's look at some code. Are there any questions at this point? So for example, this is what I will do in the code. If I put d equal to 15 here, okay, and because I do not know which will run first, okay, let me force this to run later. So I'll make this parent process go to sleep 20 seconds. Okay. So after the creation of the two process, whatever this executes something, but then this will sleep for 3. Actually, let's not do it here because this will confuse.
So
Yes, go ahead.
can we fork a child process?
Yes, a child process, but we will not do this in networks. We'll do it in OS. Okay, a child process is just like any other process.
So like what will be the return value of
Again,
the
that child process. So always think recursively. Yeah, you always think which is the process that is going to do the fork. The one that forks, that is called the parent process. The one that calls the fork. That will get a non-zero value, and the non-zero value is something.
Yeah, I understand.
And its child will get the 0. Okay, it's just the return value, and at that point, whatever variables you had will get copied there. Okay. But we'll not get into that. All we need is one level of fork for our networks. Okay, but what I meant was this will be important for us a little bit. So the same code, if I had if x equal to 0, okay, d equal to 15, okay, else sleep 20, okay, and then printf percentage d, okay. What do you think will get printed? And you had this original int d equal to 10, x equal to 4. What should get
10.
printed?
10.
It will get printed 10, exactly. Okay. But if I print it here, printf percentage d, this print will give me 15. So they're as if they're completely working on two different copies. Okay. Is that clear to all?
Yes, sir.
Okay. Okay. In that case, so is it absolutely clear? Should I go to code? Let's go to the code anyway. Okay. Let's keep it. So just give me a second. Oops. Okay. Can you see the code? So I have used a variable x equal to 3. You can see the code, right?
Yes, sir.
Yes, sir.
Okay. Okay. And then these calls you don't need to remember. They are not important for your networks thing. Okay, you'll know them in OS. But then each of this process has an ID. I just wanted to distinguish who is printing what. Okay. Because I print X from both places, you don't know which one printed which one basically. So get PID is a call that returns the ID of this process, whichever one is executing the get PID. And get PPID is a call which tells this parent process. So every process is a parent process excepting for that one initial process. Okay, it's a very interesting OS thing you will learn in OS. Okay, so I have forked equal to 0. I'll say this is the child process. Let me run it. Let me run it and then we can link it. Okay, I have the sleep there, so it's sleeping right now. Okay, so it printed this is the C 70948370 was actually the ID of the process that we had here. Okay, you can verify it. Let me write one more thing here. So you see 948537. This was the ID of your program when it started. Okay, and that is the parent process. It is coming from here. Okay, note that is the else part of that fork basically. So it is the one getting back non-zero thing. Okay, and then the child is the child process which gets 38. There is no guarantee it will be the next one, but usually it is. Okay, and this is the child process of process 37. So this get PPID is given me the parent of that child. Okay, and then I set before I change X in child. Okay, and now my parent is sleeping originally. Okay, so value of X in child is originally it got a copy of X with the original value, so it printed X in child is 3. Then I changed it here to X equal to 10. Value of X in child after change is again. I just wanted to make sure. So this get PID I'm printing at beginning to see whoever is printing. It has got changed to 10, and then the child is over. Child has returned. Okay, but then the parent is still sleeping. Parents wakes up and prints the value of X. It's still 3 because it has got a copy. The child's change to X equal to 10 has not affected it at all. Okay. Okay. So if that is clear, let me go to. Okay. So how do I use this in my concurrent server? Let's look at the code. So the server up to the accept call, everything is the same. Okay. So this is my accept call. Is exactly the code is ditto same on the server side from the iterative server. Okay. Now, but now what I do is I fork. Earlier you were just processing the client. Okay. Now what happens after the fork? Remember, think of this new sockfd and sockfd as those X and Ds that I talked about. So each of these processes gets a copy of sockfd and the copy of new sockfd. All right. Now I will have one of the processes, in this case the child process, that's what we usually do. Okay, communicate with this client that has connected, and the other process come back and wait at the accept for the next client. So in parallel, I will have one of the processes, the original parent process, coming back to wait at the accept call to get the next client connection. So any client connecting, it will come out of the accept call. And another process, the child process that I created, okay, which will basically be actually doing the communication with this client that has already connected. Okay, so this is the one that will communicate with the client. So this does not need sockfd. Remember, these are now two copies. I can close the sockfd here. It has just closed it. It's like closing a file. Okay, on the child process. The parent process is not affected at all. Okay, and then I send the exact same thing that you did earlier. All right. Now I have an exit 0 here. So they will do whatever it's supposed to do with the client and it exits. Remember, this exit 0 here basically makes only the child process exit. Both of them are executing this code. But then the parent process does not go into this part at all because its return value from the fork is not equal to 0. Okay. Child process goes in, communicates with new sockfd, exits after that. So now the parent process only does this. It does not need the new sockfd because it's going to only wait at the sockfd out there. Okay. And then this is the end of the while loop. So it goes back to the while one. It's here, CLI line here, and is accepting. Do you get what is happening? I want you to think for some time and tell. It's very simple if you understood fork. Okay. But you have to get this very clearly in your head. So before you forked, you had two socket descriptors, sockfd and the new sockfd that came out because one client has connected on it. Now you forked. So both these processes got a copy of that sockfd and new sockfd. They are now distinct things. They will communicate with the same thing because they are connected, but I don't need the copy. If I close one of them, the other does not get affected. Okay. And then I'm saying now I have two processes. Processes can run parallelly. That's why the concurrent server. One of the processes that I created will actually communicate with the client. I know for that communication it requires new sockfd. So in that one, I close the sockfd and I do the normal communication. The same message from client, message from server we saw in the sample code using this. And when it is done, it closes the new sockfd, it exits. Whereas the other process, okay, it does not need new sockfd. It does not need to communicate with this client connecting. Okay, it comes back to the while loop and then goes out here and it goes west. So if a second client connects while the first client is being processed, okay, then that other process will come out of the accept call. It will fork another process for this second client. So now we'll have three processes, two for the two clients, one for the main server. And the main server process will come back and wait at the accept call again. Each of those clients, whenever they are done, those processes will exit. Is it clear?
Sir, one question.
Sure.
Say we are working with pointers in our code, and there is a particular pointer which
I know your question. Very good question. I leave your OS people to answer that. Okay. What does the pointer mean? Right? Okay. You will need to know. Yeah, go ahead.
Yeah, so like following on the same line, I just wanted to confirm that these file descriptors which we have, they don't work that way, right? Like
they don't work that way.
Like,
actually, when I do the select call right after this, I'll tell you exactly what those file descriptors are. Not in full OS terms, but you will see they are just indexed into tables. Okay. They are not true pointers basically. But your question has a very interesting thing. Okay, but you need to understand memory management a little bit before you understand virtual address and memory management. Because pointer copying has a meaning basically. But that you will have to know a little bit more OS. So right now for our network thing, okay, think about simple like integers and so on, standard thing which does not depend on anything, so they get copied. Okay, and your other question, file descriptor thing, I'll come when I do select call. I have to explain that. Okay. Any other questions? Okay. In that case, I can run this code and show you also. Right. It will look like the same, but I'll give you that sample code anyway. It will look like the, if I run it, it will just behave the same way as the earlier. So you will not see any difference basically. So let us not do that. That is hardly anything. Okay. So I know how to write a TCP concurrent server. And TCP client does not get changed at all, basically. The client remains exactly the same. Okay. Okay. So let us now go to that other thing. So your select call business. Now this one is going to be a little bit long, but we have to understand some things. Okay. So we have to start with the meaning of this thing, file descriptor, which somebody just asked me. Okay. Now when you have used the open call in your first assignment, okay, and you get back an integer. So when you do C programming, for example, okay, the file star that you get is just a wrapper around this file descriptor thing. So the more, down to the system level thing is this open and the file descriptor that you get. So what you have, not exactly this, okay, you learn more in OS when you do file system, but something like this. You have a table which we call the file descriptor table, file table or something. Think of this, okay? And everything that you open, okay, be that a file, actually in Linux, every device is also opened as a file, okay? Everything is nothing but an entry into this table. So this is where I keep track of what is the, so when you opened a file, okay, you got back the descriptor, okay, and then when you use the descriptor to read or something, the system automatically knows this descriptor is actually that file. You have read 1,000 bytes from it so far. Okay, so where do I keep that information? That this descriptor is that file, this is where my file pointer is. I keep it in that corresponding entry of the file descriptor. Okay, so each of your open calls, for example, whatever you did, you get an F1. F1 is nothing but an index into this table. Okay, actually I will not do it here. I'll do it here because this 0, 1, 2 are special. Okay, 0 is actually your keyboard. If you want to read from the keyboard, you basically do a read call with 0 here. Okay, you want to print to the display, you do a write call with 1 here. And 2 is a standard error call. So this is what is called stdin. I'm teaching a little bit of OS, but that's okay. Okay. So anything that you open is a fun, all information about that file, its name, where is it on the disk, etc. is kept here. Normal OS is actually a 2-level thing, but let's just think about this. Doesn't matter. Okay. So when you open a socket also, okay, you get a socketd. You are actually getting an index into the set table. Okay, just the information here will be somewhat different. Okay. Similarly, your new socketd will be something here. Anytime you open something, there's something. Okay. So if you look at it, basically everything is a number. So actually socketd, when you get 7, it means that you are in the, not directly, don't worry about it, but sort of think of it is the 7th index into the table. New socketd is 233, that means 233rd index into the table. Okay, that's how the thing works at a very high level. Okay, now, so I can think of a bit pattern. Okay, okay, this is for index 0. This is corresponding to index 1. Okay, and this is the index of last entry. So think of this, the maximum number of open things. The size of it, don't worry. The maximum number of open things that can be there. And then I can, by setting one of these bits 1, I can convey an information to the thing saying that, oh, this I'm talking actually about. So let's say this is index 37. Okay. So we are talking about the file, which may be a socket, whatever device at index 7. I can pass some information for this. And the system gives you, think of it as a type, it is not exactly a type, called FD set. So this is what is called the FD set. Bit pattern with 1 bit for every n. Again, I will put something in file. I put it in code because it involves devices treated as file sockets, everything. Okay. Typically, there's 1024 or something, I forgot. So it is there. Okay. So it's not there in this. It's not there in this. It's not. This type is there. You have to create something. So just like I do int x or something, if I say fd set, say fd, okay, then this gets created for me. A bit pattern with 1 bit for maximum number of this gets created for me. Okay. Note that it just creates a bit pattern. Okay. Now I have to tell the system basically that is where the select call and the other things come in to do something with that particular 37 bit or something like that. Okay. But is the FD set type clear? It is nothing but a bit pattern. Okay. But I have sufficient bit patterns, one pattern, but basically what it means is basically, now for program, you don't need to remember this. No need to remember all these things for programming, but you need to know what the FD set is. Otherwise, things become too mechanical as to what the hell are you doing basically. Is it clear? Yes, no?
Yes, sir.
Okay, good. So anybody with a no, okay, there is nothing to be ashamed of if you do not understand something. It's not easy to learn it the first time. So any questions, please ask, okay, anytime. Even if you have crossed the topic, you say you are thinking and you say, sir, I have this question about this thing you taught, just ask me, okay? Okay. So what I will do with the select call is this. Now just go back to socket. So I know there is 1 bit for every socket that I've opened. Okay. So I'll indicate to the system, okay, that these are the sockets in which I want to wait. Okay. But before that, let me introduce some macros. Macros to, let's say, manipulate FD sets. Okay. So suppose I have declared an FD set. Let me call this wait FD. Okay. So now this is a bit pattern. Okay. So I have these things already defined for me. So if I do FD0 and wait FD, it will zero out all the bits, the entire whatever number of bits. You don't need to know the number. Okay. But then how do you set one of the bits? You set FD set and wait FD and the particular bit that you want to set. Just check the call. These two things may be in reverse order. I don't remember exactly. Okay. All right. Similarly, you can, if you have set it, you can clear it with the thing FD clear and wait FD socket. So this just changes 1 bit. It sets from 0 to 1. If it is not already so, sets from 1 to 0. It is not already so. Okay. And this other call called FD is set. Okay. And wait FD sock FD. Okay. Returns 0 if sock FD is not set. I don't remember 1 or greater than 0. So never check for 1, always just not 0. Otherwise, okay, that I have to check. Okay. The man pages will tell. So essentially, I can zero out everything. I can set one particular bit. I can reset one particular bit, and I can check if a particular bit is set or not. So system already gives you, just may have to make this calls basically. Okay. We'll write some code. Okay. But here is my command for select call. Okay. So this is an integer, max FD is an int, and then I will pass and wait FD. So this is actually your FD set start type. Then there will be two parameters that you will always set as 0. Do not worry about it. Okay. Actually, let's set this to 0 also right now. Okay. This is the timeout one. I'll talk about timeout separately. Let's just see how to make them big first of all. Okay. Or let's talk about this, because we'll kind of do that first DNS one, 2-second thing. Okay. So I will pass an ampersand, let's say time, this thing, and this is defined as a struct. Under there is underscore or not, I don't remember. Okay, int tvsec, int tvusec. All those things are there in the tutorial also. Okay, so don't worry, just try to understand. Okay, this tree always set to 0, right? Okay, I'll show you this kind of thing. What is the maximum of the FDs that you're trying to wait on? I'll show you how to set this. This is the one we'll set reset, and this is the one we'll use to do timeout. Okay, as you can see from the names, basically it means sec and usec. That means second, and it's actually microseconds. Okay, not milliseconds. So you can say 3 seconds and 3000 microseconds if you want. Okay, that's the timeout you want. Okay, so basic things understood. Now we'll kind of start writing code. Yes, no?
So what was the max FD for the first argument of select?
So max FD is basically, it says that, so suppose you want to do something with 3 and 7 and 9. Okay. These are the 3 sock FDs for whatever reason are you concerned basically. It's more for optimization. So 3 and 7 plus 9 means you will take the maximum of this. So 9 plus 1, 10, that is the max FD. So basically it is telling the system, because 3, 7, 9, 9 is the 10th bit. It's saying that out of the entire bit pattern, only the first 10 bits are relevant. Rest of them are 0 anyway. You don't have to worry about them.
Okay, so got it.
Okay. So think about our first example. Okay, suppose I have a socket, and suppose I have a technique, make a complete example. Suppose I have 2 sockets. Okay, so I have 2 sockets. Call it sock FD1 and sock FD2. Okay, so here is what I want to do. Wait on sock FD1 and sock FD2. Come out if data in any one or 3 seconds have passed. Either of this condition I want to come out. Okay, and do something. So let's do this 3-second thing first. So I'll declare a struct time val, call it T. Okay, and I will declare an FD set. Let's call it FD. Okay, now suppose these are already created and everything. So these are the 2 sockets that I'm interested in. So I will set them. First, I will zero out everything. So I'll call FD0 and FD. Then I will check a particular bit. So FD set and FD, sock FD1, FD set and FD, sock FD2. Okay, so in that bit pattern now only these 2 bits are set corresponding to the 2 sockets. Okay, and now I will set the time value. So I'll say t.tvsec 3 seconds. So I want 3, and I don't want any microseconds. So that is 0. All right, and then I'll make this select call. Again, you will check for error and all, so I am not going to do that. Select what will this be? Suppose there is a max function, okay? SOCFD1, SOCFD2, plus 1. Don't forget this plus 1. Okay, so it is not the maximum FD. The maximum FD plus 1, because if maximum FD is 11, that means it's at the 12th bit, because things start from 0. So you're telling the system how many of the bits from the beginning does the system have to check. More for an optimization. Because it doesn't want to go through the entire bit pattern to see what all other bits are. Okay. And we will pass ampersand D. Oh, sorry. Ampersand FD 0, 0, ampersand. Again, there may be small changes, mistakes by me in the syntax and all, so that you can check. But this is essentially the idea. Now, this blocks until either data in SOCFD1 or data in SOCFD2 or 3 seconds over. Okay. So think that there is no data anywhere. Okay. It will just get blocked there. Select is a blocking call. Right? Okay. Now suppose a data comes in SOCFD1. Okay. Note that I did not make any receive calls or anything now, because if I make the receive call on SOCFD1, I will get blocked. Then if a data comes in SOCFD2 also, I cannot do anything, because I am blocked in the earlier receive call. Okay. So suppose data comes only in SOCFD1. Just suppose. What will happen? Select will come out. But then now, select has come out. I do not know how it has, why it has come out. It could have come out if there is data in SOCFD1. It could have come out if data is only SOCFD2. It could have come out if data in both SOCFD1 and SOCFD2. Or it could have come out if data in none of SOCFD1, SOCFD2, but 3 seconds are over. Right? So now I have to check basically what happened. So here is what the system does. Okay. The system will, irrespective of what you passed. Okay. What did you pass? Think of there are two sockets. SOCFD1 is 1, SOCFD2 bit is 1, rest everything is 0. Okay. The system will set basically only the ones which are ready, which has data, to 1. The remaining ones will be set to 0. So in this case, if data has come only in SOCFD1, when you come out of the select call, in this FD, only SOCFD1 will be 1, rest everything will be 0. Okay, but I do not know that, so to write the code for everything. So that's where the FD is set comes. So if FD is set and FD SOCFD1. So this basically says data in SOCFD1. Okay. Now you can do whatever. Okay. You can make a receive call, whatever. Note that now you are guaranteed that this receive call will not block. Otherwise, your FD should have been reset to 0. Okay. Else if FD is set, yeah, and FD SOCFD2. So this is SOCFD1. Okay. So data in SOCFD2. Okay. So you receive SOCFD2. Okay. What is this third else case? Anyone?
Both.
No defib.
No. Both is already
Timeout.
captured. Is the timeout. Okay. And you do whatever you want to do. Let's absorb this. Okay. My handwriting has become a little bit great. Okay, my handwriting is never good to start with. But you can understand, right? You can understand what I've written. Yes, no? You can read, right?
Yes, sir.
Okay. See so now with this code thing, what will happen in the different cases? If there is data in only socket D1, okay, so let's cut this line. Then when you come out of the select call, only the socket D1 bit will be set to 1. The system will reset all other bits to 0. Even the socket D2 that you have set. So by setting initial, it's input output parameter. By setting, you are saying to the system, these are the ones that I wait to be ready. Okay, wait for something to come. So you're setting those bits. And when the system gives it back to you, it modifies the FD set again to say, these are the ones which actually has data. So if only socket D1 has data, then only socket D1 will be set to 1. So then this will become true. So it will go into this if, okay, and therefore none of this. Okay, sorry, there is a mistake. There is a mistake. It's not else. Sorry. So this, yeah. Okay. Yes. Not the return, you will get confused. Okay, because see, if I put the else here, if both of them have data, then this only one of them, only the first one will get confused. Okay, so that's not what I want. So when I write code, we actually just make it continue to the while loop above and so on. Okay? But then I need basically this is fine. This timeout code. Let me just write separately. So just think about that timeout code as if FD is set. There is usually will be a better way of writing this inside because you can always. I don't want to write return or exit or something. Then you think the code returns or exits from the function. But you can always return to the select call or go somewhere else. So if FD is set and FD socket D1 equal to 0 and FD is set and FD socket D2 equal to 0. So this is basically your timeout. So there is no else there. And you do whatever you want at one time. Okay. Okay, I'll come back to this. There is no else. So just think instead of this code, you just think of the code here I put in the next one. Okay. So this basically says what? So if only socket D1 has come, then this will be true. It will do that. Now I know that it won't get blocked here. Okay. This one will be false because system would have reset socket D2 to 0. So I will not do this. Okay. And then this one will also be false because this one is equal to 1, not equal to 0. So it won't do the timeout code also. Okay. What if data has come in both? Then it will do this. There is no else here. That's why I have to remove this. Okay. We'll again check for socket D2. That will also be set. So we'll do whatever is supposed to be done for socket D2 also. Okay. And then both are 1 means the timeout ifs will not be true anyway. So that's what gets done. And then you can go back and do something else. Again, make a select call, whatever. That depends on the application logic. And if none of them have come, then the only way the select call can come out of its block is because of the timeout. So this will not be true. This will not be true because both of them will be 0. But then this will be true. This will be true because both of them are 0. So we will do the timeout code. Are you with me?
Yes, sir.
Everyone?
Yes, sir.
Okay. So now, suppose I have done something and then I want to go back and wait again. Okay. Is there anything else I need to do? Okay. Let me answer this. This is simple. So note that it's a. Remember that FD is an input-output parameter that you set some bits and then system changes some of those bits. So you want to make the system call again. You have to again set the socket D1, socket D2 bits. Because it is possible that data has come only in socket D1, okay, but not in socket D2. That means the system has reset that socket D2 bit to 0. So you want to make the select call again. Remember the purpose of setting it. You're telling the system that these are the bits, these are the sockets that I'm waiting for. I want to wait for. So I have to set them to 1. When the system comes back, system says, since it is any, it says these are the ones out of the ones that you have told me. These are the ones which are actually ready. They have something for you to read. So that if you make those calls, you will not block it. Okay. So now your UDP server, the first question, that 2-second timeout becomes very simple. You will have the UDP socket, create it. Okay. So you will have only one socket and the timeout of 2 seconds. So you'll make a select call. When you come out, you will check if FD is set that socket. If it is, you will make a receive from call there because then you know something has come for it. Okay. If not, it's a timeout, so you will exit. So do you think you can write the first assignment, the 1A, so 2A? Ghettos by name you have to learn. Okay. That's simple actually. It's just learning any other standard C function. No networks there, nothing. You can even write a small C program to test it. I suggest you do that. With no networks on your local machine, just input something from keyboard, make that call, get the result, print it out to make sure all of them are there fine. So once you know that, you know how to send to receive from calls in UDP. The timeout was a new thing, but now you know how to do it. You just make a select call. It's only one time. Select call with that UDP socket that you create for the DNS server and the 2-second timeout. When you come out of the select, you check with FD is set, is the socket set? If so, do a receive from? Okay. And then make the get host by name call and do a send to again to send back result. This timeout, you exit. No send to, sorry, it's on the client side. So receive from this. So you have to make a select call on the client side. Server side, there is no receive, no select call. It just waits on the socket. If you receive from, if anything comes, it makes the get host by name call, gets everything. You also know how to send a variable length thing in UDP now. So that's the other thing. This is a very standard thing. So what you will get back is a sequence of strings. Okay. So how do you send? This has nothing to do just with network. Okay. In general, a series of strings. Okay. Well, how do you send is not the question. Main question is how do you detect when the string ends? String of strings end. Okay. And here we have not restricted you in this assignment to anything. So there are many possible ways. In the first case, you can just, you know what is the number of strings you want to send in this case. Your get host by name will tell you that. Okay, in one of the fields in that structure it returns. So you can first send that to the thing. Okay. And then send the other one. So client can do a one receive from for that and then another receive from for the other one. But I'll tell you a better way, okay? So that you don't have to do two receive froms on the client side. You get that basically. So the client sent a name to server, okay? And the server will send this string of strings. Each of those, so it will say like 10.14.3.7 and then so that there will be 2.5. Whatever, 12.5. Something. Okay. So each of these is a null terminated string. All right. So one possibility is you first send the number of strings that I'm going to send. So client does one receive from to do that, and then does another receive from to actually get so many strings. The entire string, so it can just now look for so many backslash zeros. When it gets, you said 4 strings, it gets 4 backslash zeros, you are done. But then you need to make 2 receive from calls. Is there any other way to send it? Okay. So you also send things like this. These are 2 full stop kind of things. Very standard way of, kind of signal representing the end of a string of strings. No more strings to send. Send an empty string basically. Are you with me?
Yes, sir. Got it.
What is the problem with this in this case? Maybe be thinking in the code mode a little bit. Remember, your name can return more than one IP. So more than one string. That's why the string of strings is coming. Okay. And remember this UDP. This message oriented. Do you see any problem? How will the client know what is the size of the string coming back? If I just make one receive from call on the client side, what is the buffer that I allocate? Because it's UDP, remember, if the server is sending me 300 bytes, because some name has a lot of IPs, okay, and the client has allocated 100 bytes, if it makes a single receive from call to make this entire string, like I said here, \0, okay, then the last 200 bytes will just get dropped, right? And if the server has to tell you what is the size, then you might as well ask for how many strings. So what do you think you should do if I don't give you any other assumptions? If I don't give you any other assumption, there's no way to do with single receive from. But you see, here is something that you know here. The size of each string is fixed. The maximum size. It can be at most, for an IP address, at most 3 characters, 3 characters, 3 characters, 3 characters. Okay. And then the 3 dots and the \0. The maximum size of each of them is fixed, but how many of them will come is not fixed. So you can do 2 things. Again, I have not given you that assumption. So right now work without the assumption. Is without the assumption, you will have to just keep on doing the receive from with select call. Okay. And anytime there's a 2-second timeout, you come out. Or you have received all the strings, then you print it. Are you with me? What I'm discussing? So these are all dummy programs, small toy programs basically. When you actually program and all, you will see this business about sending variable length things and how to predict the end is very, very important. There are many ways to do it. Right? Dot dot or backslash 0 backslash is a sentinel thing, or you send the size. Or in the next assignment, hopefully we'll do something. We'll see another way. Are you with me? Yes, no?
Yes, sir.
Okay. So right now I'll discuss with the other teacher whether we want you to give an assumption of the maximum number of things that can come and so on. If we do that, then I will send you a mail. Maybe end of meeting tomorrow, so end of day tomorrow. I'll start writing the code anyway. It's not a big deal. Okay. One last thing. So we talked about receive and all, right? UDP socket receive from, that's the blocking call and so on. But then you think about your second assignment, okay? The second part of the thing. What do you want to do? You want to block, you have one TCP socket, okay, and one UDP socket. This will block if I don't do select on a receive from. What will the TCP socket block on? First? Anyone?
Accept.
Exactly. Okay. So even before it does receive, it will block on an accept. Okay. So how do I know that a connection has come even there? Because if I make the accept call and no connection comes, I'm blocked there. Okay. And then the UDP socket, if something comes there also, I cannot make the receive from call. Right. But then not to worry. When we put that TCP socket, let's call this. This was my socket D1, just suppose. Okay. So when I put that bit in, it will come out on any blocking call. Which means if I did this select call, okay, and then if somebody has their microphone on, so if I do if FD is set sock FD1, and empty set sock FD1, okay, then the first thing that you will do is you will do new sock FD equal to accept. Okay. So in new sock FD equal to accept, now accept will not block. It will not block because if FD is set, select has come out. Note that before the accept has connection has happened, no actual data can come. But basically what has happened is, as part of connection establishment, because TCP works on a notion of a connection, some packets get exchanged. Okay. So those connection establishment packets have come. And so the accept call is bound to not block. And then you have a concurrent server. So then you will fork and so on. And then this other process will make the receive call. This blocks, but then that's not a problem. This one will come back to the select call and wait for the next one. Are you with me? So when I set that socket FD, depending on its TCP socket or UDP socket or whatever, it will come out on anything, okay, that arrives in that socket, not necessarily what you think as the data that the other side said. But even if you don't send data, even before that, before the connection or the connection establishment is also some data being sent under some control data, this sort of control path. So something has come which requires the attention of this socket. So select will come back. And since you have not made the accept call yet, you know the first call that you have to make is accept. That's why it has come. No other case, because nobody could have sent something and that could not have come. This must have been the connect call from the other side. So you make the accept call, you have a concurrent server. Okay. So you fork the server, you make the actual receive call there, and then this process can get blocked. That is not the issue, because this process has nothing to do with the UDP, the other thing that I want to do. And then this one, the original process will come back and wait in the select call again to make the next accept call for the next connection to come. And there will be the UDP server as usual, which will be waiting for if FD is set. If this is my SOC FD2, okay. If FD is set and the FD SOC FD set, not FD set. I think we called it FD. Whatever. Okay. Then this is my UDP socket, so I will make the receive from call. Are you with me?
Yes, sir.
Yes, sir.
Okay. So look up the tutorial, look at the assignment. Everything that you need, the only thing that is not there. The tutorial is very nice. You wait for something, it has not talked. It's given a big example of a socket, but then a small example of something not a socket, but very nice example to illustrate things. And I think you have all the materials. Gatehouse by name, just learn it. It's very simple. And again, always work in modules. Like Gatehouse by name, you first run with a simple C program, okay, and then once you know that that is fine, working perfectly, then you try to just send those things out. Okay, so can you do the assignment? How did you find the assignment one? Again, okay, these are the 3 places that I missed the class. But anyway, so did you find it heavy?
No, sir. I wasn't heavy. Yes, sir.
Yeah. Yeah, go ahead. Somebody else.
Yes. No, the assignment wasn't that heavy, but like a little bit more definition of what was actually needed.
For the sentence thing, right? Yeah, I know. It didn't really have. Actually, we were focusing on network calls and so on. So, yes, I understood.
Like for example, like if there would have been a standard that could have been set, then we could have like.
You mean a test thing?
Based on that.
Yes, sir. Maybe you could have given a test case that you would have run.
Yeah, but see, we cannot give you the test file on which we'll test you.
No. Like maybe an example test file.
Right, I understand, but see that I agree. Okay, you can do that, but that does not help you really, because even if it is there, you will still have the questions answered. But sir, this can happen in some other test file. So okay, the mail that I sent you, probably we should have sent you like much earlier on. That will contain only, I think that was pretty clear. It will contain only white space, dot, and alphanumeric characters. Not white space even, I said space, because white space also means tabs and these and so on. Anyway, yeah, sometimes hard to visualize the problems here. That's why, like, I understand you will have other assignments. As I said, you have to plan your time and so on. But try to take a look at the assignment and sketch it in your mind, even if you don't write code, and see whether you don't understand something, and then send it to us. Basically, we'll look at it. Basically, this one there is nothing much. Really, just you know what to do. Basically, there's no. So test cases are like, you can do that. I said www.google.com. So there is another command that you can look up. Okay. So to verify whether you're getting the right thing. So on your machine, you do an NS lookup. Okay. So you do NS lookup www.google.com. Okay. And you should see the IP addresses returned basically. So if you have 5 IP addresses, getters by name will actually do exactly the same thing. NSLOOKUP actually calls getters by name. Or the thing that will now connect to the DNS server that is set on your machine and so on. So just try with a few of them, do NSLOOKUP to see what comes. You can also look up on the internet and so on. So many places where you can run NSLOOKUP directly. And then on your machine, when you run it, give that same thing and see whether the same thing is coming on. Yes, getting printed on. But yes, I agree with you. On that front, we probably should have been more careful. But otherwise, it was okay. Well, it's just starting off. Okay, everybody is starting off. So then, when OS database and network gets together, things become a little heavy. So give me feedback when you find it too heavy or something. But then again, if you from my long experience, if something is due on Monday and you start working it only on Saturday for the first time, you will find it. There's no way out. You may not do everything together, but at least look at this and sketch the modules in your mind, write a little bit. That will help. Anyway, we'll see. Okay. So care for something else a little bit. Yes, no? That's too vague a question. So now I wanted to talk a little bit about what is the difference between this SOCFD and the new SOCFD. And this has to do with things that, so if you open 4 different windows, okay, suppose you have this TCP server running and 4 different windows with different things, browser, this, that, etc., etc. Okay, nothing gets mixed up. Everything goes in the right place, right? It's not that this browser thing goes into that browser. So how does the system distinguish that? Okay, and that also brings you to what is the difference between SOCFD and new SOCFD. How does the client's data for an iterative server, for example, the new SOCFD data lands up into new SOCFD, the new connection lands up into the SOCFD. Do you want to know that now, or has already been a long class? It's up to you. You tell yes, I will teach. If you don't, okay. So I assume there is a long class and don't want to. That's all right. Okay. Okay, then if you have any questions, ask us. Assignment is already up on Moodle. I will upload the sample code, only that one TCP server thing on the course website. And yeah, by tomorrow night, if you don't get a mail back from me, then assume that you don't have any, you cannot make any assumptions about the number of IPs that will come back. The maximum number of IPs that can come back with each. In that case, you'll have to just make them multiple receive phone calls, each getting 1 IP, because 1 IP is maximum size, you know. You're sending them as strings, so you know what the maximum size is. Okay, so I will be here still for again as last time for another half an hour or so. So if you want to ask anything, look at the assignment, ask me anything, I'm here. Otherwise, you don't have to be here. If you want to leave, you can leave also.